Factoring using synthetic division. Use synthetic division to factor the polynomials. Hint, try factors of the constant term for your trial and error. I have a 6-problem worksheet here. I'm going to go over these odd number problems 1, 3, and 5 to leave the even number problems for the viewers to do. And I recommend you just pausing the video, trying to work ahead, see if you can get this problem right. So they give you the technique. There is the remainder theorem. There are things we can use. So we're going to use, first of all, the rational roots theorem to check for possible rational errors, and they suggest using the factors of the constant term. So in this case, our constant term is 2, so we have that plus or minus 1 as candidates, and also plus or minus 2. And one thing we have to concern ourselves with here is because we don't have a coefficient of 1 for a leading coefficient, we also have a possibility of plus or minus 1/2. But my recommendation is to try these whole numbers first, because synthetic division is easier with those. So first thing we're going to do is try the 0 of x equals 1. And to do that, we're going to create a little synthetic division bracket here. The outside we're going to put the value 0, which is 1. And the inside we're going to put the coefficients of the polynomial, which are going to be 2, -3, -3, and 2 respectively. And we're going to bring this 2 down, so we're going to get 2x squared. 1 times 2 is 2, -3 plus 2 is -1, 1 times -1 is -1, -3 plus -1 is -4, and 1 times -4 is -4, and we add these together, we get a remainder of -2. And since we don't have a remainder of 0, that means that x equals 1 is not going to work. So I'm going to put a little slash through here. We're going to go down the list and try x is equal to -1, and to do that, make another synthetic division bracket, put -1 on the outside, put our coefficients here. Now there's also a remainder theorem that you can use to try zeros out. That's going to be another exercise. With the same process, bring down the 2. 1 times -2 is going to be -2, and we have -3 plus -2 is going to be -5. -1 times -5 is going to be 5. -3 plus 5 is going to be 2. -1 times 2 is going to be -2. So we get 0. So what we have is, since we have x equals -1, the factor related to that is going to be quantity x plus 1. And so we rewrite this 2x cubed minus 3x squared minus 3x plus 2. Our first factor that we've located is this one right here, quantity x plus 1. And what we have left over below is we have 2x squared minus 5x plus 2. And we're just going to factor this in parentheses here. The factors of 2x squared are simply going to be 2x and x. And then we have our middle term negative, and which means we're going to have our, for these linear binomials, we're going to have negative signs for both of them, and the factors of 2 are simply going to be 2 and 1. So there's not another way to really write this. Okay, that's going to be -2x, that's going to give us -5x. So we're going to have to get these in a different order, aren't we? So let's go ahead and put quantity x minus 2 and quantity x minus 1. And so if we multiply these together, we get -1x here and -4x. They add up to -5x. So this is going to be our factored form, fully factored form here, which is going to be quantity 2x minus 1 times quantity x minus 2. And so this is going to be our fully factored form here. I hope you see that wasn't too bad. So now we're going to skip number 2 and then go on to number 3. And here we have a cubic polynomial, and our potential rational zeros, we're going to have factors of 15. So we're going to put plus or minus 1, plus or minus 3, plus or minus 5, and finally plus or minus 15. So we have a list here of potentially 8 rational zeros, only which 3 of us can be actual real zeros. So we're going to do the same thing. I always recommend starting with the lowest numbers. Try 1. So we're going to come down here, use 1. And then we have the coefficients here. 1, 7, 7, and negative 15. And then we bring down this 1. 1 times 1 is 1. We get 8. 1 times 8 is 8. 7 plus 8 is 15. And 1 times 15 is 15. So 0. So this means that we tried, so we know x equals 1 is a 0, and consequently quantity x minus 1 is a factor. So our answer is going to start out with quantity x minus 1, and now we just have to factor this x squared plus 8x plus 15, and we do that, we're going to get quantity. We just have plus signs here, so we have plus them in each of our terms here. So x and x, what are the factors of 15 going to be? Well, just 3 and 5, because what we have here is we're going to have 3x here, and then down here we're going to have plus 5x. So that's how we get 5x up. So we're going to go ahead over here and just put these other linear binomials here, x plus 3 and quantity x plus 5. And this, friends, ladies and gentlemen, is going to be our fully factored form here. Okay, there's 4. Now the last one I'm going to do is 5, and again we're dealing with 3, so we're going to have plus or minus the factors of 3, which is going to be plus or minus 1, plus or minus 3, and then also because we have a coefficient different than 1, we're also going to have plus or minus 1/2, and also possibly plus or minus 3/2. So that gives us different possibilities for zeros. Okay, we're going to do the same process here. Start, we're going to try x is equal to 1, and our last one, we just happened to hit pay dirt on the first one. So we're going to try 1 here, and the coefficients of the cubic polynomial here, we have 2, negative 3, negative 2, and 3. We bring this down, we get 2. Oh, there we go. Pin's going to get, okay, 1 times 2, that's going to be 2. Negative 1. Negative 1 times 1 is going to be negative 1. Negative 2 plus negative 1, that's negative 3. And 1 times negative 3 is going to be negative 3. And 0. So x worked. So our factor is going to be equal to quantity x minus 1. And so I'm going to put over here on the right, I'll put equals quantity x minus 1. And remaining we have 2x squared minus x minus x minus 3. And that's going to be equal to, our factors of 2x squared are going to be 2x and x. And then our factors of 3 are going to be, of negative 3 are going to be negative 1 and 3, or 3 and negative, any order. So we can try different combinations. One's going to have to be positive, one's negative. We'll just go on the list. We'll have plus, minus. We'll try 3 here and 1. Here we're going to get plus 3x, negative 2x. Now that's that's not exactly right, but it's helpful because we're on the right track. I think what we have to do now is just change our signs. If we change our signs and make this negative here and this positive here, I think we're going to be good. So here we're going to get negative 3x, and we're going to get plus 2x. So this is going to be correct. So we're going to come right over here and write this in as quantity 2x minus 3 and quantity x plus 1. And this middle one is going to give us a 0 of, I think, 3 over 2. The one on the right is going to give us a 0 of x equals negative 1. So this is going to be our fully factored form for number 5. And then just to see what 6 is, okay, it's going to be, I'd recommend the same process. Do your factors of 5 plus or minus 1 plus or minus 5, and just proceed from there. Anyway, I hope this has been a helpful exercise set for you. You've learned something. Good luck, and thanks for viewing.